Hi, I'm Sarafina, and I will be introducing special relativity. In physics, special relativity is generally accepted and experimentally well-confirmed physical theory regarding the relationship between space and time. There are two rules about special relativity. The first one is that all the physics laws are identical in inertial frame of reference. Inertial frame of reference means that the frame is not accelerating. The second one is that the speed of light in a vacuum is the same measured for all observers, regardless of the motion of the light source. And the only phenomenon that we concern to solve our paradox is the length contraction. Length contraction is the decrease of length of an object measured by an observer who has a non-zero velocity relative to the object. Let's see an example. We have an object A and an object B, and they are moving relative to each other. So from the frame reference of B, the length of A is contracted. But from the reference of A, the length of B is contracted. But from our frame of reference, the object who's actually moving has a length contraction.
Hi, my name's Celeste. Let's say that I have a safe that is secured with a U-shaped lock that can only be opened with a T-shaped key. If the key touches the back of the lock, then the safe opens. However, someone has shortened my key a bit to prevent me from opening the safe, let's say by 0.1%. They know that to insert the key into a lock, the key has to be moving, and due to relativity, the key will be contracted and will definitely not be able to open the safe. However, on the other hand, I know that I am at rest in my own reference frame, so it is the lock that must be moving, and it is the lock that is contracted. So if I move the key with a high enough speed, one comparable to the speed of light, then the lock will be contracted to be even shorter than the key, and I will be able to open the safe. So, will I be able to open the safe or not?
Hi guys, my name is Mohamed. I'll be taking over for the rest of this video, and I'll be solving our paradox using the concepts that Serafina introduced about relativity and using the information we already know about the paradox we're trying to solve that Celeste talked about. So, we already know that we have a lock and a key, and we know that there's a distance L1, distance L2, and L1 is bigger than L2 when these two objects are at rest. So, when the key is moving towards the lock, the key will be contracted from the lock's reference frame, and this is something we don't actually care about. The only event that we care about is whether this point 3 and point 4 get in contact with each other, causing the lock to open. So, when the key is moving towards the lock, the first event that occurs is the contact between point 1 and point 2. So, their contact tells the key to stop. And so, a signal of stopping moves towards the tip number 3, telling it to stop as well. But the problem is, we do know that a signal of stopping moves at a speed of sound. So, it moves towards the tip, and it wants to tell it to stop. But the tip is already moving, and it's a very small distance away from telling the lock to open and touching it. So the tip will travel this small distance before the signal reaches the tip, causing the safe to open. To break this down into a much simpler example, we'll be using this example. Let's say we have this distance, which is 400 meters, and then we have a distance of 1 step. And at the distance of 1 step, there is Celeste. And at the distance of 400 meters and 1 step, there is me. And so, to stop Celeste from reaching the finish line, which she is 1 step away from, I will have to move at a very large speed in order to stop it, which is impossible for me to do that. So, I will need to move it will take me even more time to cut all of this distance than it would take Celeste to only cut this distance, causing T1, the time that it took Celeste to cross this distance, to be smaller than T2, the time it takes me to cross all of this distance. So we know that this tip touches this part of the lock before this signal from here reaches this point. And that is the way we solve our paradox. And if you have any questions, please direct them towards us. And thank you for watching.